Okay, I think mics are hot. I hope so. Cool. Hello everyone. Welcome to the OneClass channel. My name is Millen and I am a software engineering student at Carleton University in Ottawa, Canada. Today, I will be going over some commonly asked physics questions at both the high school and university level or college level. If you need some help with your homework or if you're interested in tutoring, check out the links in the description below. Cool. So I'm gonna switch over my screen real fast and then we can see all the physics. Cool. So let's get down to business. Let's get down to business with the physics with quickness, and let's do it with legitness. You get it? Cool. So the first question that we got today is convert 1 electron volt. Electron volts convert to joules. I'm going to assume that's supposed to be a capital J because joules is with a capital J for that unit. Okay, so first, before we do that conversion, let's think about what a what a volt is. The units for volt is joules per coulomb, meaning it is energy per charge. And we're just trying to get this into joules, which is just energy. So to convert electron volts to joules, it would make sense that, hey, what if we multiply, or this is just voltage. So if the voltage units is volts, which is equal to joules per coulomb. Now it would stand to reason, if we want to convert this to just joules, well, we're going to need to multiply something that would, if we want to multiply it so that there's a coulomb on top, so that we can cancel the coulomb on the bottom of the unit. Okay, so what charge should we use? Well, we look at the name electron volt, electron, that's a nice hint. So why don't we multiply one volt, multiply that by the charge of an electron, that should just give us a joule left, and that will be how many electron volts are in a joule. Okay, so I know the charge of an electron, and let's just do the absolute value because electrons do have negative charge, but let's keep our numbers positive for now because it'll be easier to help visualize the stuff. The charge of an electron is 1.6 times 10 to the negative 19 coulombs. The C stands for coulombs, named after the scientist, the Coulomb guy. Yeah, he was probably a smart guy. Okay, so if we multiply this by 1 joule per coulomb, well, you see how the coulomb on the downstairs here, that coulomb neutralizes the coulomb up there on the units. Whoa. Whoops. Okay, so the only unit left here would be joules. So we know that 1 electron volt is 1.6 times 10 to the negative 19 joules. Now, let's say we want to go the other direction, or I'll write this out like value of 1 EV. EV means electron volt. Okay, so if you want to go the other way, so like let's say you're given something in electron volts. So let's say you have like 1, or let's say you have like 3 electron volts. If we want to convert that convert EV to joules, well, we know there's going to be this many joules, 1.6 times 10 to the negative 19. That's how many joules are in 1 electron volt. So you multiply it like this, 1.6 times 10 to the negative 19 joules. And we know that that's how many joules are in 1 electron volt. 1 electron volt. So we do the math here. You see the EV up here and down here, they neutralize each other. So all that's left is joules, which is just 3 times 1.6, and that's going to be 4.8. Yeah, 4.8 times 10 to the negative 19 joules is equal to 3 electron volts. Okay, so got to be very comfortable and familiar with this stuff. Yeah, and canceling out units and all that. And if we wanted to go the other direction, like if we want joules and we want to go from joules into electron volts, say we have 100 joules. Well, to convert joules to EV, electron volts, we would just divide by by the fraction that we got above. So we know that we have 1 electron volt per 1.6 times 10 to the negative 19 joules. The joules on here neutralizes the joules up there. And the result of this, well, pulling out the handy dandy calculator to find out. 100 divide 1.6 times 10 to the power of negative 19. And the result of that is 6.25 times 10 to the 20. That's a big number, electron volts. And that makes sense because electron volts are significantly smaller than 1 joule. So, yeah, that would make sense to get a massive number for 100 joules. Okay, so, yeah, I guess to be more precise, you could use 1.602, but typically 1.6 is good. Okay, and I guess the junior tutor here went a little bit deeper, and I guess they showed like some applications of where this would be used in like an electric field, because that's where really the unit joules per coulomb comes from. It's like how much energy is a single piece of charge gonna have. Yeah, so yeah, the above solution is good. Above solution is good. Perhaps. Yeah, let's just say it's good. Okay, cool. Good job.